So now we're going to do my favourite thing, which is to use a number line to think about the numbers. And here we're looking at logarithms in base 10. That's important. And we are looking at a number line, and on the top here we're going, this is x, so this is the logarithm. So these are the numbers here, so we're ranging from 0 to 1, so the x values here in this table go from 0 to 1, and then on the bottom we're going to have the y, so this is the normal number, if you like. And so those numbers are going to range from 1 to 10. I'm just going to put some different things on there and see how they compare to each other. And we're going to start with the ones we had from the previous video, and then we're going to build from those and then add a couple more at the end. Okay, so the first one is, we know that 1/2 is equal to 0.5. We know that if it's the log of 1/2, when the logarithm is equal to 1/2, then our y value is square root of 10, or 3.18. Square root of 10. And we also know that if that 1/3, or 0.33 recurring, 1/3 is equal to so if our logarithm is 1/3, then our y value is the cubed root of 10, or 2.16. I talked about all this before. And then if we got 1/4, or 0.25 as our logarithm value, then we know that the 4th root of 10 is y, and that value is 1.78. Okay, so then we are going to fill in. So the other values we had, it was that log in base 10 of 2 is equal to 0.31. So log in base 10 of 2. So now we're going from the y and we're looking to see what happens to the logarithm. So the log in base 10 of 2 is equal to 0.301. So that falls just here. 0.301, and that is 2. So if our y value is 2, then our x value is 0.301, and then 3, log of 3 is 0.477. So that's here. Okay, so now I'm going to build up a few more using those values and the laws of logarithms that we've already looked at. Yeah, so these are the two we've already put on there, and we've also got 1, we've got from 1 to 10. Alright, so we're going to use our laws of logarithms. So how about if we want to know the log of 4? Now I have it in my table here, but let's pretend I don't. So if we've got the log of 4, that is equal to the logarithm of 2 times 2, which we know is the same as the log of 2 plus the log of 2, and so that's 0.301 plus 0.301, or 0.602. Okay, so we can add that onto our table here, so 0.602, that's here. How about if we've got the log of 6? So you can do a similar thing, so that's the same as the log of 2 times 3, which is the same as the log of 2 plus the log of 3, which is the same as 0.301 plus 0.477, which is equal to 0.788, which is the same as we see here. So let's add that on. So 6, 0.788. There we go. Log of 8 is the same as the log of 2 times 2 times 2, which is the same as 0.301 plus 0.301 plus 0.301, or 0.903. This is 8, 0.903. And finally in this sequence we've got the log of 9, which is equal to the log of 3 times 3, or 0.477 plus 0.477, which is 0.954. That's all the way up here, 0.954. And then, so we've got 1, 2, 3, 4. We've got 5 here on our table, 0.699. And 7, 0.845. Okay, so I'd like you to take note of two things. Firstly, of the way I've broken down these logarithms to calculate from a couple of basic things, these other guys. And also, I'd like you to take note of how these numbers kind of squash their way, squash together towards the right. As we get towards 1 or 10, depending if you're looking at the x or the y, then these values get closer and closer together. And yeah, I think that's what I have to say about that. Thank you.